National Electrical Code Article 210.11c3 addresses the number of openings permitted on branch circuits. Specifically, it states that branch circuits supplying lighting units, or a combination of lighting units and receptacle outlets, shall not have more than 13 openings for attachment plugs. This means that on a single 20 amp circuit, the total number of lighting outlets and receptacle outlets combined cannot exceed 13. This limit ensures that the circuit is not overloaded, preventing potential fire hazards and ensuring the safe operation of electrical devices. Let's break down what this means in practical terms. Firstly, consider a lighting unit as any point where a light fixture is connected to the circuit. This includes recessed lights, ceiling-mounted fixtures, and wall sconces. Each of these connection points counts as one opening. Secondly, receptacle outlets refer to the standard electrical outlets where you plug in appliances, lamps, and other devices. Each individual receptacle, even if it's part of a multi-gang outlet, counts as one opening. Thirdly, the combination of lighting units and receptacle outlets must not exceed 13 openings. This is a crucial rule to prevent overloading the circuit. Now let's apply this to the example given 6 can lights with 6 outlet receptacles in the living room and a switch on each wall, resulting in 14 openings. According to NEC Article 210.11c3, this configuration would violate the code. The 6 can lights represent 6 openings, and the 6 outlet receptacles add another 6 openings, totaling 12 openings so far. However, the switches on each wall do not count as openings for attachment plugs. Switches are control devices and are not considered points where appliances or lights are plugged in. Therefore, in this example, only the can lights and receptacle outlets contribute to the opening count. Since the total number of openings from the lights and receptacles is 12, this configuration falls within the NEC limit of 13 openings for a 20 amp circuit. To further clarify, let's explore additional examples. Imagine a kitchen circuit powering 8 recessed lights and 4 duplex receptacles. In this case, the 8 recessed lights count as 8 openings, and the 4 duplex receptacles provide 8 openings since each duplex receptacle has 2 plug-in points. The total number of openings is 16, which exceeds the NEC limit of 13. To comply with the code, the circuit would need to be split into 2 separate circuits, or some of the lighting or receptacle outlets would need to be moved to a different circuit. Consider another scenario: a bedroom with 5 recessed lights, 3 duplex receptacles, and 1 ceiling fan with a light kit. The 5 recessed lights account for 5 openings. The 3 duplex receptacles contribute 6 openings, and the ceiling fan with the light kit counts as 1 opening, assuming the light kit is wired as a single point. The total number of openings is 12, which is within the allowable limit of 13. Understanding this NEC regulation is critical for electrical safety and code compliance. Overloading a circuit can lead to overheating, damaged wiring, and potentially electrical fires. By adhering to the 13 opening limit, you ensure that the circuit operates within its safe capacity. Furthermore, it's essential to consider the load requirements of each device connected to the circuit. Even if the number of openings is within the limit, the total amperage drawn by the devices must not exceed the circuit's capacity. A 20 amp circuit, operating at 120 volts, has a maximum capacity of 2400 volt amps. It is also good practice to only load a circuit to 80% of its rating. This is 1920 volt amps. If the combined amperage of all the devices exceeds this limit, the circuit can trip the breaker or blow a fuse, indicating an overload. When planning electrical circuits, it's always best to consult with a qualified electrician who can assess the load requirements and ensure compliance with all applicable codes and regulations. They can provide expert advice on circuit design, wiring methods, and safety measures. In addition to the number of openings, other factors can affect the performance and safety of a 20 amp circuit. These include the wire gauge, the type of wiring method used, and the quality of the electrical connections. Using the correct wire gauge is crucial for preventing overheating and voltage drop. For a 20 amp circuit, 12 gauge wire is typically required. The wiring method, such as non-metallic sheath cable, also known as Romex or conduit, must be appropriate for the location and application. Proper electrical connections are essential for ensuring a reliable and safe circuit. Loose or corroded connections can cause arcing, which can lead to fires. Therefore, it's important to use high-quality connectors and to tighten all connections securely. Regular inspections of electrical circuits can help identify potential problems before they become serious hazards. Look for signs of overheating, such as discoloration or melting of wires or components. Check for loose connections and replace any damaged wiring or devices. By following these guidelines, you can ensure that your electrical circuits are safe, reliable, and compliant with the National Electrical Code. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns. In summary, NEC Article 210.11c3 limits the number of openings on a 20 amp branch circuit to 13. This includes the combined total of lighting units and receptacle outlets. By adhering to this rule, you can prevent circuit overloads and ensure the safe operation of electrical devices. Always consider the load requirements of each device and consult with a qualified electrician for any electrical work. Furthermore, it's important to note that local codes and regulations may have additional requirements or restrictions. Always check with your local building department or electrical inspector to ensure compliance with all applicable codes. For example, some jurisdictions may have stricter limits on the number of openings per circuit, or they may require the use of arc fault circuit interrupters, also known as FSIs, or ground fault circuit interrupters, also known as GFCIs, in certain locations. FSIs are designed to detect electrical arcs, which can be a sign of faulty wiring or damaged insulation. GFCIs are designed to detect ground faults, which can occur when electricity leaks to ground. Both FSIs and GFCIs can help prevent electrical fires and shocks. In addition to the number of openings and the load requirements, it's also important to consider the placement of lighting and receptacle outlets. Outlets should be conveniently located and spaced evenly throughout the room to minimize the use of extension cords. Lighting should be adequate for the task being performed in the area. For example, a kitchen may require more lighting than a bedroom. When installing new lighting or receptacle outlets, it's important to follow all applicable codes and regulations. This includes using the correct wiring methods, ensuring proper grounding, and making secure electrical connections. It's also important to label the circuit breaker or fuse that controls each circuit. This will make it easier to identify and troubleshoot any problems that may arise. By following these guidelines, you can ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns. So remember the 13 opening limit on a 20 amp circuit per the NEC, and always prioritize safety when working with electricity. It's better to be safe than sorry, and consulting a professional can provide peace of mind.